Hello, online physics students. Today we will see normal force, tension, and other examples of forces. Uh, if the force supporting a load is perpendicular to the surface of the contact between the load and its support, this force is defined to be normal force. And here is the given symbol by n. This is a normal force. Normal force. F normal, let me say. Okay. That means if the force supporting perpendicular to the surface between the load, and it's supporting. Okay. This is, we call it the force that between the load and its support, we call it normal force. Good. This is n, and the symbol n is not the unit of force, just to say normal force. Okay. uh, the word normal means perpendicular to the surface. The normal force can be less than the object's weight if the object is on an inclined plane. An inclined plane means just like this. This is an inclined plane. Okay. If this object, let me say, has a mass m, it's so in this case the normal force is less than the object's weight because it slides. Okay. We will see in the future. So normal force is a contact force. If two surfaces are not in contact, they can't exert a normal force on each other. That means this normal force is created when two objects are in contact. Okay. In the figure below, the under A, the person holding the bag of a dog food must supply an upward force. Let's say upward force F hand. Look, this person holding the food of a dog, and when holding this food, the hand of the guy exert a force upward. Okay, upward force like this. This is a force exerted by his or her hand. So this upward force is the normal force. Let me draw. This is the upward force F hand of the guy or the woman. I don't know. So its direction is upward. So equal in magnitude, and here it says equal in magnitude and opposite in direction to the weight of the food. Assume the weight of the food means the food has its own mass. So due to its own mass, it has weight, which is given by mass times gravity. Okay. So the weight here, mass times gravity, is down, opposite in direction, equal in magnitude and opposite in direction. So the upward, so the direction to the weight of the food. This force, we call it the normal force. Then B, the cart. Let me draw under B. Okay, sorry. The cart table sag when the dog food is placed on it. That's, you see, there is a bending. It shows a bending when the foot of the dog is placed on the surface, so much like a stiff trampoline. Elastic. Elastic restoring force in the table grow as it sucks until they supply a normal force or equal in magnitude and opposite in direction to the weight of the load. That means when the food is placed on the table, it shows suck. Okay, there is elasticity. Okay, that means it's stretchability, bending it shows. So in this case, the normal forces here upward and the weight is downward. That means the weight of the object is equal to the normal force, and which is perpendicular to the normal force is always perpendicular to, don't forget this one, it's perpendicular to the surface of the contact. Here is perpendicular, this normal force is always perpendicular to the surface of the contact. Here is the surface of the contact. Here it's, at this point it's the surface of the contact. Surface of the contact. Alright, let's see other cases of normal force. For this case one, the normal force at rest. At rest means assume this object has its own mass, okay, and due to its mass it has its own weight, which is given by mass times gravity. And for this object at rest, its normal force is just equal to n is equal to mass times gravity. Okay, mass times gravity, where n is the normal force and m the object mass and g the acceleration due to gravity. The second case, the normal force on inclined. Look, this inclined, let's say this is an inclined plane. In this case it has let me say x means, which is equal to, let me say, angle. Okay, x indicates what? X is the angle, let's say angle of the inclination. Okay, and this object already on the surface of inclined plane, and the normal force in this case, the normal force cannot be equal to, normal force is not equal to mg. Okay, why? The normal force or n is different from mg. Why? Because the object if is on the inclined plane and it may show something sliding. Okay, so if you decompose this the perpendicularly, okay, perpendicularly, that means this normal force cannot be calculated by using mg. So this is a perpendicular force, so we take only the normal force is equal to mg cos theta. The third case, the normal force with external downward force. In this case, okay, one moment, I saw your question. Okay, let me back to this question. Okay, already why mg cos theta cos sine x. Anyway, look this one. I understand your question. Even here, what is the angle between this and this, the surface and this object? It's already 0 degree. So the normal force is equal to mg according to our formula. That means in general we use mg cos x, or cos x. X means theta. Okay. Now mg cos, let's say theta or x. Okay. In our case, mg times cos the angle between for this normal force across, in the case of a horizontal face, is the angle delta. Okay, that means cos 0 degree. In your mathematics, cos 0 degree is equal to what? 1. So by default this equation is equal to mg. Okay, the normal force can be calculated as equal to mg. That's why on this surface we use the normal force to calculate mass times gravity. But in the case of inclined plane, look, if you see the object is on inclined plane that has angle x or angle theta, it depends. Then we calculate the normal force by using mg cos theta of x. Now I think if it's not clear, again tell me, no problem. Just comment. Okay, no need to speak, just write on the comment section. Okay, guys. Okay, thank you. Let's go to the next part. Assume we have case 3, the normal force with an external downward force with some angle. Okay, assume we have this angle x, or let me say, or theta angle, this one. Let's say the angle x or theta. In this case, the normal force is equal to mg, the weight, mg means the weight, plus F times F, this force, times sine theta. The force is downward force. Let's decompose this one. Alright, let's decompose like this. Okay, this one, let me say F, this one, this angle and this angle are the same. Let me say x because of alternate angular angle, and this one is parallel to this side. Okay, we are decomposing, and this x or theta angle, this is the horizontal. Let me say fy, I mean fx. This is the vertical. Let me say fy. So this force is decomposed with a downward force. The downward force, not directly F, we have angle x or theta. So our down, let's add all the force first. Let's add all the forces, and the summation of all the forces across the y is given by the force, the normal force, plus the weight, plus what is the other downward force? Fy. Fy is equal to 0. Alright, we have this the summation of all the force across the y. So this all the force across the y, the force across the y, the summation of all the forces across the y is equal to, or that means we are using the vertical. We are using the vertical is equal to 0. But You know, force is a vector physical quantity. Now let's put again the direction. It means look at the normal force, look at the downward force, the weight, look at again the Fy. That means the summation of all the forces across the vertical is equal to the normal forces, it's upward. For the upward case, our vector quantity is positive, okay? Fn. Then, what about the weight? The weight is downward. Direction is downward, we have negative of the weight, okay? Then Fy, again, Fy is, look, we decompose here, okay? Downward, that means minus F across the Y is equal to 0. Now take out these two quantities, the weight and the Fy, that will decompose, okay? And this one already 0, and we take out, then the normal force is equal to N, or which is equal to, when the weight is go to the other side, become positive weight, then this Fy plus Fy. This Fy means F times this force times sine x, which is equal to weight already mass times gravity plus, let me write here, okay, this implies the normal force is equal to the weight mass times gravity plus Fy means F this force F times sine x. X is the angle, okay, this x is the angle, okay, the angle, okay, don't forget, sometimes they give you theta, okay, it's common, okay. So we can calculate the normal force like this, okay, in this case, okay. Don't forget to decompose all the vertical, we are adding on the vertical force, and then put the direction either negative or positive according to upward or downward, because force are vector physical quantities. All right, let's see the case for, again, in this case we have the normal force with external upward, look, okay, here we have an upward force, this force is upward. Now let's decompose. It means we can decompose this as like this. Now this surface is parallel to this surface, okay. Now in your mathematics, according to this angle is equal to this angle, let me say x, this is the horizontal, okay, this is the vertical. We decompose this one is for the horizontal we have fx, and for the vertical we have fy. We are using this upward force, okay, the decompose, no need to don't use directly this force, okay, just we have to decompose because we have angle theta, okay. So we can, let me, okay, right. So we have to add all the vertical force, okay, all the vertical, the force across all the vertical is equal to we have what, the normal force plus the weight plus what are the other vertical, look, we decompose this force into Fy, okay, this, let me say Fy now is equal to 0. Let's see again the values either positive or negative after we take out or we write in this form. Then the summation of all the force across the y is equal to the normal force its direction upward or downward. Look, the normal force is upward. Okay, that means it's positive. Let me write like as it is. What about the weight? It's negative or positive? It's the weight is it's downward. You can, so it's negative. So minus W weight. What about Fy? Fy now in our case it's upward force, and we decompose the F into F times sine theta. That means it's positive in this case. Okay, that means plus Fy is equal to 0. In the previous case it was down. Okay, it was down and the force is down. Okay, in case 4 it's upward, so Fy become here positive, and for the downward here Fy become here become negative. Okay, after this let's take out these two quantities to the right side. This implies normal force is equal to, when the weight goes to the other side it becomes positive, and Fy when it goes minus Fy. So this we can put all the values. The normal force is equal to weight means mass times gravity, then minus Fy means this, Fy means F times sine x. Okay, this is the derivation. All right, good. If you have any question, please write to me, or if okay, good. Is this clear? Okay, good. Let's see one example. An elevator normal force, a 4-kilogram package of kiwi flavored bubble gum is being delivered to the top floor of an office building. You have given take out the given mass is equal to 4.5 kilogram. The box sits on the floor of an elevator which accelerates upward with an acceleration 3 meters per second square. The delivery person is also resting 1 foot on the package, 1 foot, exerting a downward force on the package. The force of the person, let me say, is equal to 5 Newton. What is the normal force you are required? What is the normal force is equal to how much, or N is equal to how much? And here is the diagram. The normal force always it's upward force. Okay, here we have the force of the gravity downward according to its mass, like this. The object is on inside an elevator, and the man assume here is an elevator. Okay, inside there is a mass, the mass of a kiwi, and the man, this man already, let me say, he puts a 5 Newton force with his foot. It has the object has its own mass, and this elevator is accelerating upward. Okay, assume it's accelerating upward, and there is a normal force also here, it's upward. Now you are required to find the normal force. All right, now the solution we can find by the summation of all the forces on the vertical. Let's see, on the vertical we have what, one, we have the normal force, it's upward, normal force. Then The other, look, let me write on the, let me show you on the rail pen. Look at these two things. The man with the foot, the man applied with his foot 5 Newton force, and according to this object, it has also got its own mg or weight. Okay, so we can write as its direction is what, downward. Again, the man exerted the force downward. That means we can write it as directly minus what, because instead of going 2 steps, minus mg, the weight, again minus the force applied by the person or the 5 Newton force, is equal to look, Fy, the summation of Fy. In this case, we are not going to make it 0, okay, because the object accelerates upward. That means mass times acceleration, because it accelerates. In the previous case, of examples, we add what, the net force, the summation of the net force or the upward is 0, 0, because it's rest. Okay, for example, here, again here, it's rest. So all the summation, we don't have any net force, but in our case it accelerates. Please attention, it accelerates. So the summation of the force across the y is equal to the normal force, which is upward, minus the weight because it's downward. Look at also the free body diagram, minus the force applied by the man with his foot. It's downward. Okay, it's downward. That's why we use negative, is equal to mass times acceleration. Now it's simple. Now this implies the mass is 5 kilogram. 5 kilogram times the acceleration is 3 meter per second square. Okay, is equal to the normal force. The normal force minus mg minus force of the person. This can be decomposed as 15, this 5 times 15 Newton, okay, is equal to the normal force minus mass, it's already 4.5 kilogram, sorry, here 5.4 kilogram. Okay, sorry, here we made a mistake. I made a mistake, sorry, because here only the mass is, the mass is 4.5 kilogram, and when we multiply that one, around 13.5 Newton minus again here mass time minus 4.5 kilogram times acceleration due to gravity is 9.8 meter per second square minus the force applied by the person downward is 5 Newton. Now this the normal force is equal to 13.5 Newton minus plus 4.5, because we take all these two quantities to the left, kilogram times 9.8 meter per second square plus 5 Newton. This implies the normal force is equal to around 62.2 Newton. You can use your calculator, okay? No problem. It give you this one, okay? If you have question about this example, again, please send me. Okay, yeah, thank you. Very the second example, let's see. Find the normal force of a block with a mass 4.2 kilograms sitting on a raft with an incline of 45 degrees. Oh, it's something like the object put on an incline like this. Assume, let's say this one is theta or x 45 degrees. Assume you have one object, okay, for this incline, has its own mass, okay. You have given the mass is equal to 4.2 kilogram, and you are required to find the normal force F normal or N is equal to how much. Solution, it's on inclined ramp, okay, so it's similar to this inclined plane, okay. We found the normal force, or N, is given by M times G cos theta. We already seen this mg cos. It's similar to this one, okay. So the mass is already 4.2 kilogram times gravity already. Take G always 9.8 meter per second because it's popular, times cos 45 degree. Now we can use our calculator, okay. We can use our calculator. It means we can okay, let me okay, 4.2 times 9.8 times cos no sorry, sorry, use our calculator. Let me write 4.2 times 9.8 is equal to 41.16 times cos 45, and the unit will be Newton, okay. Then we multiply by cos, oh, my calculator is a sheet, it's not, cos 45. Okay, this already give you 41.1, which is around 21.29 point, let's say 41. Yeah, that's about today's lesson, okay. If you have any question, you will come, okay. Just a moment, send me this credit, guys. Okay, good. So see you in the next lesson. Until then, bye bye. Thank you. Thank you.